So this is another example where I will solve this equation. So this involves a double angle identity. So I have cos 2 theta, and I'm going to substitute one of these. And what I do want to talk about is which one to pick. Notice how you have a sine theta here, which you can't replace with anything else. Like, it's not a Pythagorean equation that you can't replace it with a Pythagorean identity. So ideally, when you want to replace the cos 2 theta, you want to replace it with everything related to sine so that this whole equation flows. So if I replace it with this, it's going to be an issue because I have sine cos squared theta. And then if I replace it with this, I'm going to end up with another cos, so I haven't done anything. But replacing it with this is ideal because I have an expression and equation in terms of sine only. So I'll replace it with that. So I have 1 minus 2 sine squared theta plus sine theta. So by doing that equals to 0. By doing that, what I have, hopefully you have now been able to notice these. This is a quadratic expression in terms of sine. So you can move everything to the other side if you want to make this positive, but you can actually solve this without a calculator. And you will get that sine. I'm going to skip the steps where I do the solutions. This is a quadratic in sine, but you will get that sine theta is either equal to 1 or sine theta equals to negative a half. So things to note in both of them is that this one is positive, so we're looking at the first and the second quadrant. This is negative, so we're looking at the third and the fourth quadrant. Now we're in terms of pi in radians, so solving these, you should know that this is equal to pi over 2, and that's the only solution. So there is no other angle that will give you sine theta equal to 1 within the 0 to 2 pi. So I've mentioned in the previous video where I solve another trig equation is that you need to think of this as the coordinates here. And this is negative 1, 0, and 0, negative 1. So remember that sine is your y value, so this is your sine. And the only time that sine is equal to 1 is when it's here, when it's the pi over 2. So that's the only one within the 2 pi, within one rotation. So this is the only solution. And then we come to here, and the way to solve this is, I've mentioned before, you can either do it for a positive or a negative. I'm going to do it for the positive just to get the associated angle, so the acute angle. So this will be pi over 6, but this is the first quadrant. So to get in the third quadrant, I'm going to take pi and add pi over 6 to it. And then for the fourth quadrant, I'm going to take 2 pi and subtract pi over 6 from it. And hence, I'm going to get this as 7 pi over 6. And this will be 11 pi over 6. So in the end, I have 3 solutions. So I have this 1, 2, and 3, not the first quadrant because we don't need it. We're talking about third and fourth quadrants. And do check your answer by substituting in and seeing that you actually get 0, preferably in the first expression and not in the simplified ones.